Hello everyone and welcome back to another video. Today we'll be continuing with our chess engine, and in this particular video we'll be starting the engine evaluation. So this is definitely the most exciting part of the entire program. We've gone through all the basic functions, so this is basically just the foundation functions as well as the interface side, and just last video we concluded our look through the legal moves as well. So now we'll be going through the engine evaluation. So what exactly this entails is first determining whether the square is under severe attack. This is a very critical function, which we did use a bit in the previous legal moves, but then we'll be using it significantly more now. And then also a very exciting function, which is the evaluation function. So what the evaluation function does is basically determines the evaluation of a particular board, which, as you can imagine, would be essential for a chess engine. So let's have a look at the is under severe attack function today. And then in the next video, we'll be taking a look at the evaluation. Okay, so if you want to follow along on GitHub, as I'd recommend you do, it's basically on line 479 is where we start the evaluation functions. Okay, so let's have a look at is under severe attack first. So pretty much what this function does, just in a nutshell, it determines whether a particular coordinate square is under severe attack from the pieces of the opposing player. So now why would this be useful? So let's say if we were doing an evaluation of a position and a square was like a square which contains the queen would be under severe attack, i.e. like it can be attacked by a pawn as well as a knight and a few other pieces from the opposing pieces, sorry. So this basically means that this is basically bad for the color which owns the queen, right? Since most likely the queen will, most likely they're in a worse position. Not always, but most likely if the square can be attacked several times, it's not necessarily good to, for the piece to be there. So which is why this is under severe attack will be very useful in the evaluation function, which we'll be going over in the next video. So how we do this is we basically need to go through all of the pieces in the opponent's pieces, and then we basically differentiate based on which sort of piece it is. So if it's a knight or a pawn or maybe a bishop or a rook or bishop or a queen, and then if for all of these we basically need to determine whether that particular piece could possibly attack the coordinate squares which we are after. So basically for what we do is this basically just initializing a bunch of variables. We've done this a few times now, but I'll just quickly go through it. So the color basically, remember the fourth bit of the coordinates determines the color. So the fourth bit divided by 8 gives us 0, 1. 0 corresponds to black, 1 corresponds to white. That's basically the color. Then this piece number is basically the piece number. Opponent's pieces are whatever the current color is, and then 1 minus that to give the opponent's piece locations. And then all pieces is just basically a deep copy of opponent's pieces. It basically is just an array of all possible pieces. This will come in handy later when we look at pinned pieces and stuff. And then what we do is we also append attack. So what we initially do is we initialize attack to having one variable which has an infinite value. And now the reason why we do this will come very apparent a bit later on. Okay, so now let's look at all the possible different pieces. So what we're exactly aiming to do is, for each of these pieces, if that piece can basically attack the square which we're after, then we append that particular piece number to the attack array. So now let's look at a pawn. So for a pawn, basically, if the color is 1, then it basically means that its direction of attack is going to be vertically upwards. So then it's basically, if the color if the color is basically 1, then that means that the color of the piece which we're currently looking at would be white. But then that means that the direction of attack will be coming from black, so it'd be vertically downwards. So that would correspond to vectors of 1, 1, and 1, minus 1. 1, 1 goes here, 1, 1, 1 minus 1 goes here. Okay, so that's basically if this particular condition is met, or the other one. So the other one is basically if the color is black, so i.e. the color of the piece we're currently attacking is black, so the opponent's pieces would be white, then the direction would be in the opposite direction. So which is why this color is for the opponent's pawns, which is why we have these two particular direction vectors. If either of these are met, and the pawn is basically attacking the particular coordinates which are after. So then we append 1 to attack array. So this 1 is basically just a piece of a pawn. So then we append that to attack array. And then if the piece number is basically 2, this means if it's a knight, then our criteria is basically if the absolute of the direction, so if the direction vector, if the absolute is basically 1 or 2, or 2 or 1, then we basically append it to the attack array. So now the reason why we use absolute is because if you imagine a knight's moves, it's basically through the vectors 1, 2, or 2, 1, or 1 minus 2, 2 minus 1, etc., etc. It's basically any vector which has magnitude 5, if you like. So this basically means that the absolute of the vector, of the x and y coordinates of the vectors, would either be 1, 1, 2, or 2, 1. If this condition is met, then we basically append it to the attack array. And now for the next piece, which we have, is we basically need to look at the bishop. So now one thing which we've done here is, if you might notice, we have piece number 3, or if the piece number is 5. So now a queen's movement is basically identical to bishop and rook's movement, right? So if the bishop can attack it, then so can the queen. Which is why this particular if loop not only applies just to the bishop, but it also applies to the queen. So if the piece number is 3, or the piece number is 5, i.e. the piece is a bishop or a queen, and we basically have this particular condition. This basically means that the direction vector is basically equal in magnitude, the x and y are equal in magnitude. So the reason why we do this is because if you imagine a bishop's movement, it's basically across the vectors 1, minus 1, 1, 1, minus 1, minus 1, or minus 1, 1. So this basically means that the absolute of the x and y coordinates would have to be the same. So which is why we have abs direction 1 equals abs direction 2. If this condition is met, then we go down this if loop. So then what we do is we basically first need to determine what the scale of the attacking vector is. So this is basically just whatever the abs of direction 1 is. Excuse me. And then what we do is the unit vector, which is basically the vector of 1 square in that particular direction. That would basically be the direction 0 divided by scale, direction 1 divided by scale. So now let's just look at an example in case this is not that clear. So let's say the direction is minus 3, 3. So then what would happen is the scale would be 3, and then the vector would be minus 3 divided by 3, so minus 1, comma 3 divided by 3. So the unit vector would be minus 1, 1. And now what we need to, the reason why we're doing all this, and not just doing this condition, is that for a bishop to attack a square, one more condition needs to be met which wasn't needed with the knight and the pawn. The condition which needs to be met is that no piece needs to be in the line of sight from the bishop to the attack square. Okay? So what we do is we basically, this particular while loop just deals with that particular condition which we have. What we do is start is basically the vector addition of the previous start variable as well as the vector, and then the vector being the unit vector, and start being initialized to whatever the piece location is, but then it constantly gets updated to checking the next location, which is across the unit vector. So basically checks every piece within, every square within the piece which is being attacked, as well as the attacking piece. And then now, if this particular square is in all pieces, i.e. it's a valid piece, it's a piece which isn't the coordinates, or it's out of bounds, then what we do is we basically, this is the break condition. Since if the start is in all pieces, this basically means that there's some other piece which is inside the line of attack. This piece, the color is irrelevant, but it's basically just another piece which is hindering the attack. So if that's met, or if the range is basically out of bounds, then we basically need to set valid to false. However, if the coordinates, if the start is equal coordinates, which would be basically like if the start is equal to the coordinates of the square which we're attacking, then that's valid. So we basically break, we don't set valid to equal false. Since remember, the coordinates of the square we're attacking would fall under all pieces, which is why we have this condition. If that's met, then we basically break and set valid to equal false. And now only if valid is true, then what we'll do is we'll basically append the piece number to the attack array. So that's basically what we have for the bishop and the queen. And now we need to do the thing for the bishop, for the rook and the queen. And now one more thing which you might notice is that we have if over here, however we have lf the rest of these places. And now the reason why we have if is because a queen can actually, it could be any one of these. So for example, if the queen were to enter this block, then a queen can also be considered a valid move if it's part of this block. So which is why we need to do an if instead of an lf. Now will actually work if we use an lf, but just in case, like it's just a good practice just to have like a if in case we change the code a bit later on in the future. So so now let's see how we do it for a rook. So the movement for a rook is actually very similar to that of a bishop. So this part of the code is basically identical. However, we have one more criteria for a rook. So basically for a rook, to determine the unit vector, it's not as simple as for a bishop, since there are basically, a rook's movements are basically either horizontal or vertical. So this basically means that if the x vector is 0, then that means that it's going in vertically. So this could be up vertically or down vertically. So now if direction 1 is basically positive, then it means it's going up vertically. Now if it's less than 0, then that means it's negative, so it's going down vertically. And now otherwise, we basically do the converse. So then it's basically moving either left or right. So these vectors will be updated correspondingly. And now what we basically do is we basically need to do the same for a bishop, except we have this other condition. So this is basically the new set of conditions which determines whether the vector is out of bounds. So it's basically whether the start 0 or start, or whether the coordinates of start basically out of range. However, over here we only need to determine whether the coordinates were out of range in one direction for a bishop, but in here we need to do it for two. But otherwise it's pretty much exactly the same. So yeah, that's how it works for a rook. And now now we've basically gone through this main for loop, and now let's look at this line of code. So and basically what is under severe attack aims to do is it aims to return whether a square is under attack from a piece of lesser value. So this basically means that let's say a knight is being attacked by a queen. Now this could still be a bad situation, but then if the knight's being attacked by a queen but it's defended by a pawn, then it doesn't really matter, right? Like it's not detrimental in any way, since the queen's not actually going to take the knight. So what we need to do is if the piece number is greater than minimum of attack, so this basically means that the square is being attacked from a piece of lower value, or if the number of attacking pieces are greater than 2. So this basically means that several pieces are attacking the king, the piece, and or this piece number is not equal to 1. This bit of code is actually unnecessary. I'll tell you exactly why I have that though. Like it's an interesting reason, but it's not necessary in this particular code. So the reason why we have it, the reason why we have this is because if it's being attacked by several different pieces, then we basically then it might actually be under attack. So for example, to go back to our queen analogy, if a knight is being attacked from a queen and two rooks at the same time, then it's probably going to be a bad situation for the knight, because most likely it has more attackers than defenders, so it'd be a bad situation. Okay, so now the reason why I had that is because if you remember from the function which we had to determine whether a king is in check, it was actually very, very similar. We pretty much used the identical same body of the function. We just have to change a few different parts of the code. So for the isCheck function, what we had to do is determine the attack square, as well as whether any pinned pieces were present. However, how I made the isCheck function was actually from this is under severe attack. Initially, as part of the code, I had both of these under one function of the is under severe attack, which is why I had that extra bit of code over here. However, as I realized determining the legal moves for a king was becoming increasingly complicated, I split them into two separate functions. But this is just a nice way of how this function could have been reused for determining several possible things. So that was one of the main functions within this, within the evaluation functions. But in the next video, we'll be looking at probably the most fun and most enjoyable function which we'll be coding in this particular series, which is the actual evaluation function. But that's basically it for this particular video. I really hope you enjoyed watching. Hopefully you learned something new about how we implemented this particular part of the chess engine. And if you did, please be sure to leave a like and subscribe. It would be very much appreciated. And I hope to see you in another video next time. Thank you very much for watching. Bye.